everybody. Now we will go on to problem 3. We are still in problem set 1.1, and now we are in problem number 3. And we need to see how much is v plus w and how much is v minus w. Okay, let's see it first algebraically, okay, by numbers, and then geometrically by drawing. Okay, so first we will see it by of course in the future we will not we will use more and more the algebraic way, the way with the number, and less the way with the drawings, but still it's nice to see sometimes the drawings also. Okay, so we have v plus w is 5, 1. Okay, v plus, I'm sorry, it's a vector, so we need to put a small arrow. So v plus w, which is another vector, so it also has an arrow, is 5, 1. First component 5, second component 1. And v minus w is another result, is 1, 5. First component 1 and second component 5. Okay, so when we have this v looks like a vector with 2 components, and w looks like a vector in 2 components, okay, because or else they couldn't have given we couldn't add them and get this result, this sum. And so let's like draw them and call their and we will call their components in names. Okay, this is the first step in order to turn them into simple equations of simple variables. Okay, we want to have equations eventually like v1 plus v2, like v1 plus w1 is equals something, and so on. Okay, and v2 plus w2 equals something, and so on. So v, let's look at v as v1 and v2. Okay, these are the 2 components of v. And w, we will look at it as w1 and w2. These are the 2 components of w. And we don't know what v1 is, what v2 is, what w1 is, what w2 is, but we will know very soon. Okay, so let's write the first equation in this way. Okay, so v1, v instead of v. Okay, instead of v here, we are writing this v1 and v2. We are just copying this equation, the first equation, and translating it into this language of more specified components. Not saying V in shorthand, but more specifically, what does V stand for? V1 first component and V2 second component. V1 and V2 plus, instead of W, we will write what W stands for, W1, W2. Okay? So, and what does it equal to? It equals to 5, 1. Okay? A vector with first component 5 and second component 1. Okay. And now we are interested in this equation. How can we turn it from an equation which uses vectors, one vector and another vector and another vector, which we don't know how to solve, into an equation that a normal equation, a simple equation with simple variables. We just remember how we add vectors, one component at a time. This much apples with that much apples gives this result in apples, and this oranges with these oranges gives this amount of oranges. So exactly the same, one equation for apples, one equation for oranges, one equation, simple equation with simple variables for the first components, and one equation for the second, another equation for the second component. Okay, let's do it. So V1 plus W, let's write it below what each one below its vector. So V1 plus W1 equals 5. Okay, this is one equation of the first component. And and another equation, okay, would be the second component, V2 plus W2 equals 1. V2 plus W2 V2 plus W2 equals 1. Okay, so we have two equations and we have 4 unknowns. Okay, this is a variable, this is another variable, and another variable. Okay, so it's like we have A, B, C, and D, and we have only 2 equations, and we need 4 equations, right? So where would we get 2 more equations to solve all the 4 variables? We get them from this equation. Okay, the one with the that I'm encircling with the yellow marker. This equation would give us 2 more simple equations. This is one equation, but this is in vector language, and when we translate it into simple equations, it will be it will turn into 2 simple equations, and then we will have in total 4 equations. We have already 2, and then we will have 2 more, and we will have 4 equations. Okay, and this is what we need. Okay, so we are just trying to get the most information out of what data we have in the beginning. So if in the beginning we have this we use, and we cannot use it anymore. Now we turn our attention into this equation. Okay, so we do the same process. We turn it into specifically what it says. It says V, which is V1, V2, minus W, which is W1, W2. Okay, so let's write it. V1, V2 minus W, which is W1, W2 equals 1, 5. Okay? And now let's turn this one into two equations, okay? Like we did here. So the first equation would be the first components, V1 minus W1 equals 1. V1 minus W1 equals 1. And V2 in the second equation would be the second components. This minus this equals this. V2 minus W2 equals 5. V2 minus W2 equals 5. Okay, let's copy it in a clean way. Okay, I'm taking this and this, and we're putting these two like together. I'm not summing them, but I'm putting them together. Maybe the plus is confusing. Okay, so let's copy them to a new page. V1 plus W1 equals 5. V2 plus W2. Okay, now let's not just copy them just like that, because we can do better. We can take this equation that has V1 and W1, think of it as like, you know, A and B, okay, and V2 and W2 is like C and D, okay. So if we add, I'm just erasing this because maybe it will confuse you, and let's do this. We'll take the first equation here, okay, this one, and put it with this equation here, y, the first here with the first here. Why? Because this contains the same two variables as this one, okay? And then if we instead of dealing at the same time with all the 4 variables, we will deal each time with just 2 variables. We have 2 variables and the same 2 variables, and we have 2 different information, you know, pieces of information about it. Let's see how we do this. Imagine it was A plus B equals 5 and A minus B equals 1, okay? We're just not translating everything into A and B, but if it's easier for you, you can say we are marking V1 is A, W1 is B, and then translate everything into A plus B equals 5, A minus B equals 1, and then at the end, when you have an answer, translate back. And remember, instead of A, write v1 equals something, instead of b, write w1 equals something. Okay, but we will do it directly in v1 and w1. Let's do it. v1 plus w1 equals 5, and v1 minus w1 equals 1. Okay, we have these two equations. Okay, we can forget about this page. We have these two equations. What do we do with them? We can add them together. Okay, if we add these two together, we make a plus between them. Here we will have, why can we add this? You know, it's not linear algebra, it's just simple algebra. If we have something equals another thing, and we have something else equals something else, we can add these two, and then they will equal the sum of these two. Okay, like if we have, for example, I'm just showing you why it's allowed to sum together two equations, why it's okay in a logical way. Okay, if we say, okay, it's not part of linear algebra, it's part of normal algebra, simple algebra, but we are just refreshing our memory. Okay, for example, if we had cakes, okay, small cupcakes, which are equal to a big cake. Okay, let's say we had, forget this for a moment, if we had small cupcakes, okay, and a small cupcake, let's draw it like this. On this side we have a cupcake. Okay, this is I don't have a color for chocolate, so I'll do it in black. Okay, let's say the black is chocolate and the white is cream. Okay, so this is a cupcake, and it equals chocolate plus cream. Okay, let's say this amorphic shape is the whipped cream, the sweet white stuff that you make from fat of milk, you know, and chocolate, you obviously you know what chocolate is, and ignore this. So a cupcake is made out of cream and chocolate, and let's say we add another set of these. Okay, plus cream equals another cupcake. Okay, if we sum them together, okay, let's say even another one. Okay, and as many as we want. And if we sum all these equations together, you agree that in each equation, this side of the equation, the left side is equal the right side, in each equation separately. So if we add all of this, okay, we add and get a big chunk of chocolate, plus we add all of this, we get a big chunk of cream. This equals to a big cake, not just a cupcake, a big cake, and a big with big cream. Okay, I hope this makes sense. Okay, this is a huge cake. Okay, a big cake. Cupcake is like a small cake, like a personal serving, and this is like for the whole I don't know, the you and your friends. Okay, so you understand, if in each equation, in each small equation, the left side equals the right side, so the sum of all of them, we can sum them and it will still be equal. The left side, the sum of all the left sides will be the equal to the sum of all the right sides. Okay? Okay, so I hope it makes sense. So now let's return to what we to the numbers, to the variables and the numbers we have here. It's allowed to, okay, we have two equations and we can add them and get a third equation, and the sum of the left sides would be equal to the sum of the right sides. Okay? So let's do this. And of course, I'm sorry, just once more, it's okay to run it backwards also. If we subtract, okay, if we do the opposite of adding, if we take this chocolate and subtract small amounts, but and the same small amount we subtract from the right side, we get an equation. Okay, so we can add equations and it keeps giving an equation. If we add the each side separately, we get an equation, and also if we subtract equation, it's also, we are allowed to do it. Okay, so let's do it. Okay, so v1 plus v1 gives us 2v1, right? v1 and v1, 2 times v1. We can write a multiple sign, or we cannot. We can just write it 2v1, 2 times v1, and the plus w1 and the minus w1, okay, the plus and the minus, we have the same amount, okay, so some quantity that is called w1, and one time we have it in plus and the other we have in minus, and it's the same quantity and it cancels each other out. Okay, so plus w1 plus minus w1 together give 0. Okay, so we don't write anything, or we write plus 0, which is the same. Okay, plus 0, which is these two added up, and equals now the right side. 5 plus 1 gives us 6. Okay, so 2 times v1, ignore the 0, equals 6. So v1 equals 3. Okay, v1 equals 3. Okay, so this is one piece of information, and if we take this and put it inside one of the equations, for example here, and instead of v1 we will write 3. Okay, let's write it in green. This is 3. Okay, So if v1 is 3 plus, maybe the parenthesis confused, I just write 3. Okay, so 3 plus w1 equals 5. So w1 equals 2. Okay, so we can write here w1 equals 2. Okay, and this is the second variable that we found. This was the first one, v1 equals 3, w1 equals 2, and in the same way now, like we will do it quicker, but in the same way we will find from the pair of two other equations. Now we dealt with these two, the orange and circle, this one and this one, and now we will take let's put them in red. Now we will take this equation and the bottom one. Okay, so let's do that. So we have v2 plus w2 okay, can you see it? v2 plus w2 equals 1. And v2 minus w2 equals 5. If it's hard for you to think about them with the indices, with the little 2's, you can think about them in terms of if this was A and B, you can think of v2 and w2 in terms of C and D, some other variables. Okay, so you can call v2 in the name C, and w2 you can call it D, and solve these two equations. C plus D equals 1 and C minus D equals 5, and after you solve it, just remember to exchange back to the names of the original variables what came about to be C. It's really v2 equals what C equals, and the result you got for D is actually w2. Okay, so let's do it directly with v2 and w2. So the first equation was this one, and now we will take the other one, v2 minus w2 equals 5. Okay, two equations. Again, we can add them together, and we get the left side total will equal the right side total. We can even write the equal before. So v2 plus v2 is 2 times v2 plus w2 minus w2 cancel each other out. We can just write 0 plus 0, or we can just ignore them, and 1 plus 5 is 6. Okay, so 2 times v2 equals 6. So 1 times v2 we can, divide by 3 both of the sides of the equation, and get v2 is 3. Okay, if we have v2, we can put it here, and instead of v2 write 3. Okay, and 3 plus w2 equals 1. So what is W2? W2 has to be minus 2. Okay? If it's confusing to do it by heart, we can write it down. 3 plus W2 equals 1. Okay? So we subtract from each side of the equation 3, and we get W2 equals 1 minus 3, which equals minus 2. Okay, so W2 equals minus 2. Sorry, it didn't show up in the camera, but it's like really, you should be able to do this even by yourself. And now we know everything. We know what V2 is, we know what W2 is, and we know what V1 and W1 are from before. Okay, so just we will look at all of them together. We will just write them all down. V1 is 3. I'm just copying from the other page. W1 equals 2. Okay, it's here. And V2 equals 3. And W2 equals minus 2. Okay, now they asked us not what V1, W1, V2, W2 are. They asked us what is the what is V and what is W. Okay, so V as a vector is V1, V2, right? So V, right, I'm reminding you, V equals V1, V2. And we know V1 and we know V2. So it's 3 and 3. Okay, the first component is 3. And the second component is also, by chance, it happens to be 3 here. And W equals, okay, W is W1, W2. So the vector W. So we know W1, which is 2. We know W2, which is minus 2. So we write it down. The first component is 2. The second component is minus 2. Okay, so now that we have both of them, they ask us to draw. Okay, so let's draw. Let's draw the two vectors. We will make a coordinate system. Let's start with the horizontal axis, x. Okay, then we will remember that this is the first axis, the first component. And we will also draw the second component, which is the second axis, which is the y, the vertical one. Okay, so x and y, the first component, the second component, and now we draw these two vectors. And let's do them with different colors. For example, I don't know, like orange for V. Let's do V, or maybe in red. So V equals 3 and 3. and in green we will have W equals 2 and minus 2. Okay, we will make the small dots like 1 and 2 and 3 and 4 and 5 and 1 and 2 and 3 and 4 and 5 and 1, minus 1, minus 2, minus 3, minus 4, minus 5 and minus 1, minus 2, minus 3, minus 4. Okay, and now let's draw. So V is 3 and 3 plus 3 in the x positive direction to the right, 1, 2, 3, and then 3 up in the positive y direction, the second component, 1, 2, 3. Okay, so we got here, it's 3 to the right, 3 upwards, it's here. Let's make it an arrow from the origin to the point that we found there. This is V. Okay, and let's draw W also. It's 2 in the x positive direction, so 2 to the right. Okay, and in the y component, in the second component, it's minus 2, so it's in the negative direction of the y-axis, down 1 and down another step, so it's down 2. So 2 to the right, first component, and 2 down, second component. So it's here. Let's draw. This is the point, but let's draw the arrow. Okay, this is W. Okay, now they ask us, what is V plus W? No, I'm sorry. They told us in the beginning that V plus W is 5 and 1. Okay, you remember? V plus W is, the first component was 5 and the second was 1. So let's see if it's really true. Okay, if we draw, we go along V, and then we go along W, which is 2 to the right and 2 down. Okay, let's do it. V plus W. So from here it's 1, 2 to the right and 1, 2 down. This is W. So we really get V plus W is 1, 2, 3, 4, 5 and 1 up. Okay, just writing, this is 1 and this is 5. Four, 3, 2, 1. Okay, so if we go directly to this point, we get the vector of the result, which is what we got in the beginning. Let's make it in orange. Okay, if we go directly from the origin to the end point that we got here, okay, so this is V plus W. In orange. I hope you can see. And the other thing that they want us to draw is V minus W. Okay? V minus W is this is V, and minus W is flipping W in exactly the opposite direction. Okay, so if W is 2 and minus 2, so minus W, let's write it in purple, minus W is each component gets negated, okay, gets minus. If it was positive, it gets minus. If it's already negative, it becomes positive. If it's minus, it gets plus. Okay, so minus 1 times each component. Minus 1 times 2 is minus 2. Minus 1 times minus 2, minus times minus, it's plus. So it's just 2. So minus 2 and 2. So we have here in the x direction minus 2 here, and plus 2 is 2 upwards. It's a shame I decided to write it exactly where it's like the worst place, but never mind. This is minus W. Okay? This purple arrow, okay, minus W. So if we want to add V plus minus W, which is our way of doing V minus W, we add V and the opposite of W, minus W. So we do the same. We draw V, and then we go along V, like walking along V, and then along the minus W copied to where we start. We started in the end, in the head of the V. Okay, so we walked along V, and then we walk in the direction of minus W and the size of minus W. It's like we copied this to here. Let's do it. We do minus 2, okay? We walked along V, like this. And then came to here. And from here, the head of the arrow of V, we go in the direction of W. So it's minus 2 in the X and 2 in the Y. Minus 2 in the first component. The X component, which is minus 2, is 2 to the left. So it's 1, 2. And from there, 2 to the plus 2 in the second component, which is the Y component, which is 2 up. Okay, 2 in the positive plus direction of the component Y. So it's 1, 2. So we get here. Okay? Can you see this point? Okay. So this is like copying minus W, this vector, from the origin to here, which is allowed. We said that a vector is defined by, it doesn't have to come from the origin, it just has to be in the same size and the same direction as the one that do come from the origin. So this one is minus W, but also this one is minus W because it's the same direction as this one and the same size. Okay, so this one is also, just trying to make the purple color stronger. This one is also minus W. Okay, and if we want to see how much is V plus minus W, in other terms V minus W, we go straight to where this one ends. Let's make it in blue. From the origin, V minus W. Okay, so we go from the origin directly to there. And this blue arrow is V minus W. V minus W, which is 1 in the X, okay, 1 in the X component, and 1, 2, 3, 4, 5 in the Y component. Let's write this 2, 3, 4, 5. Okay, so this point is 1, 5. Okay, so and this is what we were given in the question. They told us that V minus W is first component Y, second component is 5. Okay, so this V minus W equaled 1 and minus 5. So everything fits, and if we wanted, we could have calculated the equations from the drawing, but you see it's much easier to do the equations by numbers, and in the future, if we have more dimensions and even more than 3, okay, so we can't even draw, and we will have to rely on the equations, okay, and not the paintings. But the painting is nice just to see that we did it right. Okay, so thanks, and goodbye.